Okay, so let's move on to the second function, g of x. It's defined as a step-size function, okay? And it says like this: when x is not equal to 1, and then my function is defined as x squared minus 1 over x minus 1, which you can see that, which is exactly our f of x for the first part, okay? However, at x equals 1, g of x equals 1, okay, equals 1, okay. So you can see that we can draw the graph for the first part, right? Which is exactly copy the first piece, paste it here. And also we need to add one more part, which is when x equals 1, g of 1 equals 1, which I put this big dot here, okay? So that's a graph for g of x, okay? And then last one function is very straightforward, which is h of x equals x plus 1, okay? And you know, the domain is over a number, and we just plug in. You can see that this is a straight line, okay? And now we look at those three functions. Those three are different functions, right? But I'm gonna ask a question like this, okay? So if x approaches 1, okay, what gonna be fx getting close to? Okay, let's think about that. As x approaches 1, fx approaches to a value, a fixed number, something. Let's do the explore right now. Looking at here, guys. When my x approaches 1, do you agree that you actually have two ways to do the approach? Either you can starting a number is greater than 1, right? I don't know, maybe something starting from here. And then you get close approaches to 1, right? And then you can always also start a number smaller than 1 and then getting close to 1, right? So this actually is a very, very important concept. It's called the one-side limit, okay? Every time when we claim limit of something, it's gonna always have two sides, okay? In other words, guys, when we talk about the limit as x approaches to some constant number, let's say a, okay? You have to consider about either x approaches a from the right and x approaches a from the left. Okay, so now let's see. So if I start from a number is greater than 1, and correspondingly, as you can tell that the corresponding y value is here, right? So label that. As x getting close to 1, do you see that my corresponding y value actually is getting approaches to 2 from the top, right? Similarly, as x approaches 1 from the left, which is from a smaller number, you will see that the corresponding y value, it also get approaches to 2, but from the lower part, okay? In fact, guys, this is a function here. This is a, we can decompose it, this arrow, into when x approaches 1 from the left, the corresponding y value before it was from here, it get approaches to 2 from the bottom. Okay, similarly, this one gonna approaches to 2 from the top. So in other words, these two arrows, it's a combination of how the function moves, okay, as our x approaches to 1. Okay. And let's look at the second one here. Again, as x approaches 1, okay, either from the right side or the left side, do you agree that your corresponding y value, something from here, right? Starting from here, it actually getting approaches to 2 either from top of or the bottom. Okay? And if we describe this progress, right, you will see that when you trace this curve, either is from the right side of 1 or left side of 1, you will see that those two gonna approach to this point, and the corresponding y value, which is also 2. Okay. Third one, even simpler, right? When x approaches 1 either from the left or right, the corresponding y value gonna approach to 2. Okay. So from those 3 graphs, what we can tell, guys? As you can see, limit as x approaches 1, fx approaches to 2 for those 3 functions, right? And you can see, guys, at x equals 1, whether my function is defined or defined into a different value or is not defined, it doesn't matter. Do you see that? For example, in our first case, fx is not defined at x equals 1 because x cannot be 1. So we put an empty circle there, but limit still exists, which is 2 as x approaches 1. Okay. Second one, my function is defined as x equals 1, but it is not 2. But still, it does not affect the existence of a limit as x approaches 1 g of x, which is 2 here, right? This one, everything is well defined, also works. Okay, so this is what we can see. First of all, let me put a notation here, guys. This is what we can write. Limit LIM x approaches 1, fx equals 2, okay? And this we describe as limit as x approaches 1 of fx equals 2, okay? We can also see that limit as x approaches 1, g of x also equals 2, right? This one, limit as x approaches 1, h of x also equals 2, right? And so a note here is note. So the existence of limit as x approaches a, f of x has no relation with the definition at x equals a. Okay, so it's a little bit smaller, but you got the basic idea. My x at x equals 1, not defined, limit exists. My x at x equals 1 defined, but may not be the value 2, still limit exists. Okay. The third case is okay, my value at x equals 1 is defined and it's 2, and that also equals my limit. Okay. So the idea is the existence of a limit as x approaches to point has no relationship with the definition of the function at that point. Okay. So that's about the limit. Now let's look at, okay, a function may not have a limit at a given point, okay? For example, let's look at this one, okay, this case. So this is a function, and this is the point A here. As you can see, guys, if I'm asking, let's see if this is called fx, okay? This is called gx, let's still keep that, this is called hx. The question is, limit as x approaches a, fx exists? Big question mark, okay? Let's check. As we just discussed, as x approaches a, we have to consider two sides, okay? And you can see, guys, if I start to trace the curve, as x approaches a from the right-hand side, it's gonna give me a value here, while as x approaches a from the left, do you see that it's gonna give me a value like this? Do you agree that those two one-side limit does not match, right? Because the left side limit equals give me a value like this, right side limit give me a value like this. Those two does not match. Then we see that, okay, limit as x approaches fx does not exist, okay? And when we see a limit exist, it must be from both sides, and then the corresponding y value must approaches to same value. In this problem, one side limit exists, yes, but they are different. So, exist? No. Okay? Big no here. What about this one? Let's look at this. Limit as x approaches 0, g of x exists? That's the question. If you can see this actually is a graph of y over x. Okay, y over x. As you can tell, as x approaches 0 from the right side, g of x goes to positive infinity. While as x approaches 0 from the left side, then g of x goes to negative infinity. So still, one side limit does not even exist, right? Then we can get the conclusion, no. And by the way, guys, when we claim a limit exists, that limit must be a fixed number, okay? And also, if a limit goes to infinity, we'll just write limit of a function as x approaches something equals infinity, okay? But still, that limit does not exist, okay? Last case, h of x. Okay, I will not write into this, but just let you think about this. Assume this is the point A here, and the graph might not be very clear, but let me give you some brief idea here. It's kind of like you have an oscillating function here. As x approaches A from the left-hand side, the oscillating is becoming more wild, okay? So as you can see that as x approaches A from the left, the limit already not exists, not even mention that the limit as x approaches A, right? Because we don't even talk about from the right-hand side. Okay, so I hope this is going to give you some brief idea about the concept of limit, and we'll continue with this section with more examples. Okay, so see you soon.